4.2 Electrical Quantities Memo. Question 1. A. State the unit of electric charge. Well, it's the coulomb. Do light charges attract or repel? Well, they repel. Does the electric field enter or leave a negative charge? It enters. D. For the following materials, distinguish whether they are conductors or insulators. Well, copper wire is a conductor. A plastic ruler would be an insulator. A wooden meter stick would be an insulator. And an aluminium can would be a conductor. Define electric current is question number 2. It was the rate of flow of charge or a flow of charge carriers. B. A calculator cell has a current of 20 milliamps. How long would it take for 10 coulombs of charge to leave the cell? Well, Q equals IT, so Q over I equals T. 10 divided by 0.02, remember we need to convert from milliamps to amps, and we get 500 seconds. C. State the direction of conventional current flow from a battery's terminal. Well, it's from the positive to negative terminals. D. Explain the fundamental difference between alternating and direct current. Well, the current direction changes every half cycle in alternating current, whereas in direct current, the current flows continuously in one direction. Number 3, define electromotive force. Well, the electrical work done by a source in moving a unit charge around a complete circuit. State the unit of EMF. Well, it's the volt. Question C, define potential difference. It's the work done by a unit of charge as it passes through a component. And D, state the unit of potential difference. Well, exactly the same as the EMF, it is the volt. Question number 4, a battery has an EMF of 9 volts across its terminals. Given that 0.5 coulombs of charge has left the cell, how much work has the battery done? Well, V equals W over Q, so voltage is work done divided by the per unit charge. V times by Q is going to give us W, so 9 times 0.5 is 4.5 joules. Number 5, a resistor has a current of 50 milliamps flowing through it, measured passing through it, and with a potential of 12 volts placed across it. What's the value of the resistance of the resistor? Well, V equals IR, so V over I equals R. 12 divided by 0.05, I get 240 ohms. Sketch the Ivory Curves for a constant temperature, filament lamp, and diode. Well, for a constant temperature, it's a straight line curve because the resistance isn't changing. Then we have in the middle, we have a filament lamp. So for a greater increase of voltage, the amount of current gained actually becomes less and less and less because the resistance of the filament lamp is increasing. And then finally with the diode, well, effectively nothing will happen until you get just over a threshold voltage. Then the current will flow through the diode. Up until that point, nothing will happen, and in the opposite direction, of course, nothing will pass through the diode. Number 7, a wire has a resistance of 5 ohms. If the length of the wire was tripled, without changing any other dimensions or what the material is made out of, or what the wire is made out of, what would the new resistance be? Well, if you're tripling the length, then you're going to have 3 times the resistance, so 15 ohms. Then now the cross-sectional area is doubled without changing any of the dimensions of the wire or the material. What would be the new resistance? So if you double the cross-sectional area, you'll in fact half the resistance, so it'll now be only 2.5 ohms. Question 8, a phone charger has a power rating of 15 watts. If the voltage of the terminals of the charge is measured as 5 volts, how much current flows into the phone? Well, P equals I times B. So 15 divided by 5 is 3 amps. B, if the phone takes 1 hour 30 minutes to charge, how much charge has been transferred to the phone's battery? Well, Q equals IT, so 3 times 90 times 60, you get 16,200 coulombs. And finally, question number 9, a kettle has a power rating of 2 kilowatts to 2,000 watts. How much does it cost to boil the kettle for 6 minutes if the price of 1 kilowatt hour is 30 pence? So firstly, how many kilowatt hours are we dealing with? Well, we've got a device of 2 kilowatts and it's on for 6 minutes of 60. So 2 times 6 divided by 60 is 0.2 kilowatt hours. 0.2 times by 30 is going to give us 6 pence.